Good morning, children. Stay safely at home. Today I'm starting a new chapter, that is flow of liquids. Now, liquid, when we are considering, according to the concept of physics, we consider ideal liquid as which liquid has two properties, which exhibit two properties, that is zero compressibility and zero viscosity. So I repeat, ideal liquid means what? Ideal liquid means which exhibit two properties, that is ideal liquid has zero compressibility and zero viscosity. Now I am discussing point wise. What is the meaning of zero compressibility? We know that whenever we exert pressure or anything, then it compresses the body, means it volume decreases, isn't it? Means whenever there is a change in pressure on a substance, on a body, then the volume changes. Alright? Zero compressibility means that when you are exerting pressure on it, pressure on the liquid, but there will be no change in the volume of the liquid. That is known as zero compressibility. Then the point is coming, zero viscosity. So first of all, what you have to understand, what is viscosity, although I will discuss it in details later on. Means when you are considering a liquid is flowing, then you may consider as if the liquid is being divided into different layers, one layer after the other. So when the liquid is flowing, then what happens? One layer try to move over the other. Then along the surface of the liquid, layer of the liquid, a tangential frictional force acts which opposes the motion of one layer over the other. That's why what happens when a liquid flows, then a force acts between the layer of between the two moving layers. All right. So zero viscosity means what? Means that when the liquid is flowing, then there is no tangential frictional force acting between the successive moving layers. That is the meaning of zero viscosity. So ideal liquid means which have zero compressibility, means whose volume will not change under the action of pressure, and which has zero viscosity means there is no frictional force acting along the flowing liquid. Alright, that is the concept of ideal liquid. Then the concept of when a liquid is flowing, then we may consider that liquid may undergo two type of flow. One is known as streamlined flow, another is known as turbulent flow. So what is the meaning of streamlined flow? That you try to understand. Streamlined flow means when the liquid is flowing at any point of the path, whenever any particle of the liquid will come, it will move with the same speed as the preceding liquid, and it will also follow the same path as the preceding liquid. Very easy to understand. When you go for prayer, you know that assembly program, when you go, then how you go? You form a line, systematically, regularly you move, isn't it? So like that, when the liquid particles, they are moving systematically, regularly, okay, then the flow is known as streamlined flow. And what is the concept behind that? At any point, if you consider what is the direction of the velocity, suppose it is the path along which liquid flowing, then at this point, what is the direction of velocity of the particle coming, liquid particle coming? It will be at along the tangent drawn at that point. So you see, Suppose the velocity is v at this point. What does it mean? Whenever any liquid particle will come to this point, it will move with the velocity v. Not only that, all the particles move along the same path. Alright? Then this path is known as the flow of the liquid is known as the streamlined flow. So I hope you can remember this is similar to the concept of electric lines of force and magnetic lines of force. Alright. So to a streamline, if you consider a streamline, then at any point of the streamline, if you draw tangent, then that tangent represent the direction of flow of liquid at that point. Just like the electric lines of force and magnetic lines of force. I hope you can remember that if you draw the tangent at that point, that represent the direction of the intensity of the electric field or magnetic field. Like that, when it is streamlined, then the tangent drawn at any point, it represent the direction of motion of the liquid particle at that particular point of path. Alright, so that is known as the streamlined flow, and this line, it is known as the path along which the liquid is flowing, that is known as the streamline. Alright, so suppose you are considering the point here on the path, then what will be the direction of motion of the particle, liquid particle at that particular point along the tangent drawn. Okay, then the concept of streamline, this is a line. Alright, then the concept of streamlined tube is coming. Okay, streamlined tube means what? It is a very simple thing that if you consider a tube which is formed by successive streamline, then that is known as the streamlined tube. Alright, so the concept of streamlined flow and streamlined tube is important. You must remember the concept. Next kind of flow is turbulent flow. So as I said, the next kind of flow is known as the turbulent flow. Turbulent flow means that the particle, it is not following any regularity, any rules and regulation, any way, any direction, with any speed, all the particles are moving. Means there is no similarity between the speed or direction of motion of the particle. Then it is known as the turbulent flow. Alright. Now, the flow will be streamlined. When you are considering the flow of a liquid, the flow will be streamlined or turbulent. It depends on the velocity of the liquid. Alright. If the velocity for certain limiting minimum value of the liquid, you will see that the flow of the liquid becomes streamlined. And when the velocity of the liquid crosses that particular limiting value, then what happens? The flow becomes turbulent. Alright. So this minimum limiting velocity, okay, below which the flow of liquid is streamlined, is known as critical velocity. Very important concept in this chapter, important for your exam also. So that's why everybody should learn and remember the definition of critical velocity of the liquid. So what is the concept of critical velocity? It is that limiting velocity below which the flow of the liquid is streamlined and above which the flow of the liquid is turbulent. Alright. Now, the expression for critical velocity, it has been found experimentally that critical velocity depends on the coefficient eta is the coefficient of viscosity of the liquid, rho is the density of the liquid, and d is the diameter of the tube through which the liquid is flowing. So, we see critical velocity, it depends on eta, rho and d. Okay, from that concept you are getting Vc is equal to some constant k eta by rho d. So this expression for critical velocity you must remember. Now this k is a very important term in physics. K is known as the Reynolds number. It is a pure number. Okay, k is known as the Reynolds number. It is a pure number, and depending on the velocity of a liquid, it will be, the flow of the liquid will be turbulent, stable, unstable, everything. It also depends on K, because VC depends on K. So the flow, the nature of the flow, the type of the flow, it also depends on K. Alright, and remember always that K is a pure number and it is known as Reynolds number. When the value of K is less than 2000, then the flow of the liquid is steady, stable, and it will always be streamlined flow. What does it mean? That stable and steady means if it is, as the flow is streamlined, it will always maintain the streamlined flow only. Alright, then when the value of K is greater than 1000 but less than 3000, then the flow becomes unstable. Unstable means what? You may observe that at this moment the flow is streamlined. Next moment you may find that the flow has become turbulent. Alright. So there is a switch over between the two kinds of flow. That is the understanding of the this one, unstable flow. Is that clear? And when it happens, when the Reynolds number is greater than 1000 but less than 3000, and when the value of the Reynolds number is greater than 3000, then the flow will always be turbulent. Alright. So these are the important concept. Another important concept is that when the flow of the liquid is streamlined, it means if the velocity of the liquid is less than the critical velocity, then viscosity controls the flow of the liquid. Density of the liquid has no role to play in it. Alright. But when the flow is turbulent, in that case, remember, viscosity has no role to play. In that case, density of the liquid and effect of gravity, that means controls the flow of the liquid. So here I have summarized all the points you are supposed to learn and remember. So kindly note it down in your notebook, and you must remember and learn and remember. Don't forget, these are the important points for your exam. So you must remember it. Then coming again, the concept of viscosity. So as I said already, whenever you are considering a liquid flow, flowing liquid, in that case, what you can consider as if the liquid is being divided into different layers. And when the liquid is moving, one layer is trying to move over the other. Alright, in that case, what will happen? That there will be a tangential force which is acting along the layer. Means this is the way. Tangentially, the force is acting, which is opposing the relative motion of adjacent layers. Alright, the force is known as the viscous force, and the phenomena or the property is known as the viscosity. So what is the definition of viscosity? The property of a liquid by virtue of which it opposes the relative motion between the adjacent layers is known as the viscosity. Alright. Now there are so many practical examples in our life, and this is also one concept that you will see. If the liquid is thick, just like honey, then coal tar, these are thick liquid, isn't it? And if you consider water is thinner. So if the liquid is thick, then viscosity is more. Viscous force acting between the layer is more. And if the liquid is thin, then viscous. That's why you see, if you take certain amount of coal tar and certain amount of water, alright, and certain few drops you take, not that one bucket of coal tar or one bucket of water, and then on a table or on glass, you just pour them, you will see that water moves through a longer distance, whereas coal tar gets stopped. Why coal tar gets stopped? As I said, that due to viscosity, because one layer, the motion of the adjacent layer are opposed by the viscous force. Is that clear? And we are having this experience also in our practical life, that suppose you have taken a funnel or you have taken a tube, and through the tube you are pouring honey, and another tube you are using for water. Then you will see that honey takes longer time to come out from the funnel or the tube, but water comes out easily. Why? Because viscous force is more in case of honey, because honey is thicker whereas water is thin. That's why it is viscous force of water is less. That's why the same reason that if you work in air, then it is easier for us to work, but if it is difficult to work in water. Why it is difficult to work in water? If you compare the viscous force exerted by air and water, viscous force exerted by air is quite small, whereas viscous force exerted by water is quite large. Is that clear? The same reason that if you consider the cloud particles, why they float? Because when they are coming down, then due to the viscous force, their velocity under gravity, the cloud particle, why the cloud under gravity not coming down and settling down on earth? It is not happening, no? Why? This is the cause, that viscosity, viscous force of the air exerted on the cloud particle stops the cloud to come down under the effect of gravity. So these are all examples of viscosity or viscous force in our day-to-day life. Now coming the concept of viscous force. So if you consider the two successive layers of liquid, then you will see that if this is the V is the velocity of the liquid, the upper layer, if it is V plus dV, then lower layer it will have the velocity V. There is a decrease in the velocity. Alright. Why there is a decrease in the velocity? Because the motion of this layer is opposed by the viscous force. Alright. Now, Newton said that viscous force, it depends on, who has said? According to Newton, our superstar in physics. According to Newton, viscous force, it depends on two factors. Alright, what are the two factors? Area of the layer. It depends on area of the layer and depends on velocity gradient. You know, the change in velocity per unit length perpendicular to its direction is known as the velocity gradient. So you see, what is the change in velocity? dv, and what is the distance between that layer? dx. So what is the change in velocity per unit length? It is dv dx. Now here the point you have to understand is that the length I have taken perpendicular to the direction. I have not taken the length along the direction of motion. So whenever you consider the change of any quantity perpendicular to its direction, then that quantity represent the gradient of that particular quantity. Alright, like that we are having temperature gradient, we are having the force gradient, all these things, it is coming. The main concept behind gradient is per unit length. When you are considering, the length should be taken perpendicular to the direction. So here you see velocity gradient, if you can write it as dv dx. Why I have written dv dx? Because they represent the very small change, and in calculus when it is infinitesimal small change in any quantity, then we represent it by dv. Generally we represent any change by delta V, but when the change is very small, then we represent it by dV. So in this case, remember that viscous force according to Newton depends on area of the layer and velocity gradient. So one can write F is proportional to A into dV dx. So F is equal to some constant into dV dx. This constant, it is known as coefficient of viscosity. Here just follow what I am saying, that it is coefficient of viscosity of the liquid. Alright, so here lies another important concept. Although viscous force depends on the area of the surface, Alright, it depends on velocity gradient, but remember that coefficient of viscosity of the liquid, it is independent of the area of the surface, it is independent of the velocity gradient. Coefficient of viscosity, it is completely depending on the nature of the liquid. Alright, so this, the important point you should never forget. Although viscous force depends on the area of the liquid and the velocity gradient, but the coefficient of viscosity, which is constant for a liquid, it depends only on the nature of the liquid. It does not depend. Who does not depend on A and dVdx? Eta. Eta is the coefficient of viscosity. Next is coming, what is the dimension of eta? I have not shown the derivation because in the dimension analysis chapter, you have done it already. Alright, what is the dimension of eta? M L to the power minus 1, T to the power minus 1. And what is the SI unit of eta? SI unit of eta is decapoise. Alright, here decapoise, when you are writing, remember that all should be written small. Okay, no capital. Decapoise, and if you write it in base unit, SI unit, if you write in base unit, what it will be? kg m to the power minus 1, second to the power minus 1. And there is another unit of coefficient of viscosity which is known as poise. And remember the relation between decapoise and poise, because mostly we use the unit poise. Alright, so that's why you have to remember both the units and the relation. 1 decapoise is equal to 10 poise. Alright, so I repeat the concept once again. Eta depends only on the nature of the liquid. Eta does not depend on the surface area and velocity gradient of the liquid. So next is coming few concepts associated with viscosity. As the first point already I mentioned, that coefficient of viscosity, it depends only on the nature of the liquid. It does not depend on the surface area or the velocity gradient. Next is another very important fact, and you know the viscosity and surface tension chapter, these two chapters is so interesting because every day in our day-to-day life we use the concept of viscosity and surface tension. Now at 20 degrees Celsius, the viscosity of the liquid, this is more than that in gas. Okay, so you see here, when you are considering any liquid at 20 degrees Celsius temperature, you know that in our country the average temperature, if you consider that during the summertime it is higher, but you may almost say it is around 20 degrees, isn't it? And so that's why how we use this concept of viscosity and surface tension in our data. When you wash your clothes, isn't it? Always it is advised, when dirt is more, it is sticky. When I will come to the surface tension chapter, then I will give it again, I will give you the explanation. And in this case also, you see here what happens for liquid. If you increase the temperature, viscosity decreases. So what happens? The liquid can flow easily. That's why when you, for washing cloth, another point is there, that is associated surface tension, that I will discuss later on. So when you increase the temperature of the liquid beyond 20 degrees Celsius, around 50 to 60 degrees Celsius, then what happens? Viscosity decreases sharply. So liquid can flow easily. You are using water, no? So water can flow easily within the container where you are that you are using to wash your cloth. That's why always we use this concept of viscosity, that when the viscosity, when you are increasing the temperature of the liquid, then viscosity of the liquid decreases sharply. Alright, but for gas, remember, this is the effect of temperature also on viscosity. But for gas, the effect is reverse. For gas, what happens? If you increase the temperature, viscosity increases. Then viscosity affected by pressure also. If you consider liquid, for liquid, viscosity increases with increase in pressure. But remember that for water, it is just opposite. For water, if if you increase the pressure, then viscosity decreases. Alright, but and for gas also, and for gas what happens? Viscosity is independent of the pressure. For gas, viscosity no way depends on pressure. Then coming the effect of density. When the density, as already I discussed it, that honey and water example already I have given, that when the density increases, viscosity of the liquid increases. But for gas, just opposite, that when density of the gas increases, viscosity decreases. So I have written all the thing point wise. You are supposed to learn and remember all the points, because these are the important concepts related with the viscosity. So what are the factors that affect viscosity? They are temperature, pressure, density, but for gas only temperature and density, not pressure. Okay, in case of pressure, in case of gas, viscosity is independent of pressure. Now we will apply our concept of viscous force on the body when the body is falling through a liquid. Understand the difference. So far, whatever I have discussed, I talked about a flowing liquid. Alright, the liquid is flowing. Clear? And then I have discussed the viscous force. Now what is happening? A body is falling within a liquid. Alright, or if you consider a liquid drop falling through a gas. Alright, both the cases you can apply the concept. So what is happening and how it is happening, that you have to understand. So let us consider there is a body and it is falling through a liquid. Now we can consider as if the liquid is being divided into different layers. Alright. So you see, when the body is falling down, then what it is doing? It is dragging the liquid layer along with it in the downward direction. It is trying to drag the liquid layer along with it when it is falling down in the downward direction. Alright? So, liquid is not Gandhiji. So, what liquid will do? Liquid will not be ready to go with the body. So, liquid will oppose the motion. Means the liquid will apply an opposing force on the movement or motion of the body. Alright? So, that opposing force that is exerted by the dragged liquid layer on the body is the viscous force exerted by the liquid on the body. Again I am repeating, don't be confused. The viscous force, the term viscous force, when I applied previously, it was the viscous force acting between two adjacent layers of the flowing liquid. One layer is exerting on other. But here the situation is completely different. One body is falling through the liquid, and when it is falling through the liquid, while falling, it is just trying to drag the liquid layer along with it in the downward direction. As a result, liquid layer exerting a force, opposing force on the motion of the body. So you see, if you consider the body is falling down, then the viscous force exerted by the liquid, it will be opposite to the direction of motion. Alright? So just try to understand, if you consider a raindrop is falling down. Alright? So why it is falling down? It is falling under the action of gravity. Gravitational force is pulling it down. Alright, so what should happen? That under the action of gravity, when the raindrop is falling down, then the velocity of the raindrop should increase with time, isn't it? Means it should have an accelerated motion, velocity is increasing, and if the velocity increases this way under the action of the gravity, then what should happen? That raindrop should strike the ground with a large velocity. As a result, explosion may occur. As a result, steam will be produced. Okay, but have you ever seen that raindrop coming down, falling, striking the surface, and that is happening? No. Why? This is the cause. Alright, why it is happening? When the raindrop is falling down through the different layers of air, it is trying to drag the air layer in the downward direction. So what the air layer is doing, air layer is exerting the viscous force opposite to the direction of motion. That's why what is happening after some time, the viscous force and gravitational force, they balance each other. And when it is balanced, then not only gravitational force, other forces are there. I am coming to that discussion. What is happening? The velocity of the raindrop becoming constant. It cannot increase infinitely under the action of gravity. Okay. So that is the nice concept of physics behind motion of a body when the body is falling through a liquid. Alright, and this concept of viscous force, expression of viscous force given by Stokes, the physicist Stokes. That's why it is known as Stokes' law. Very interesting one. It is known as Stokes' law. So according to Stokes' law, when a spherical body of radius r moves with the velocity v through a liquid of coefficient of viscosity eta, then the viscous force exerted by the liquid on the body is given by 6 pi eta rv. Very famous relation, and you are supposed to remember it lifelong. Okay, viscous force exerted by a liquid on a moving body is given by 6 pi eta rv. Alright, eta is the coefficient of viscosity of the liquid, r is the radius of the spherical body, and v is the velocity with which the body is moving. Thank you children, that's all for today.